Welcome to Silicon Valley Buzz. No, that's not my name. That's the name of a new program here on KMVT, one that will treat interesting stories here in the Silicon Valley, which of course itself is one of the most interesting stories on the planet. With possibly the greatest concentration of high-tech expertise in the world, with more than 1 million people who are interested and active in solving some of the problems of the beginning of the 21st century, the Silicon Valley is endlessly abuzz with invention and new ideas. Well, that's what we're going to be talking about here on Silicon Valley Buzz. New ideas that will change your lives and the lives of your children. I'm Seth Shostak, and I'll be your host tonight for this first episode of Silicon Valley Buzz. The producer is Janet Wu. And we're going to talk electric cars tonight. I have two guests in the studio. To my left here, Tim Collins, founder and president of KleenSpeed Technologies, a company developing electric car technology here in Mountain View. And also Dante Zavaria. Dante Zavaria is Executive Vice President and Chief Technology Officer at KleenSpeed. All right, gentlemen, electric cars, you're in the electric car biz, but these cars run on electricity that itself is mostly generated by fossil fuels. So what problems do electric cars solve?
Well, you know, I think, first of all, your electricity is generated generally 50 miles from your home. So it's not like you're filling your garage with carbon monoxide or you're having to breathe the fumes of the car leaking exhaust ahead of you. So I think there's just for the quality of life factor. And then you can slice it many different ways, but you can say if you take coal power and electric car, it might be producing 60% of the pollution of an internal combustion car. That's kind of like the worst case. It's
but is that because the coal-fired power plant is more efficient because it's bigger than an automobile engine?
Exactly. It's much more efficient. And well, I don't know if it's more efficient actually, because coal is not that efficient. But it's just more efficient in the sense that the electric motors are more efficient.
Okay. Well, if I use a gallon of gas in a conventional vehicle, as opposed to say the same gallon of gas to produce electricity to run one of your electric cars, for example, is there a difference there? Will I be able to actually cut the amount of fossil fuels that I burn by any significant degree if everybody switched to an electric car? I mean, is it for real?
That's a good question. You see, even though that we're, the energy that's in 1 gallon of gasoline is about 34 to 35 kilowatt hours. So you can go on a gallon of gasoline today, maybe 30, 40 miles at best. But you see, the efficiency of the electric vehicle is far greater than a typical 15 to 20% efficiency of internal combustion engines. So for the same amount of energy that you find in a gallon of gasoline, you can travel much further if you have an electric vehicle at home.
Okay.
So that's one difference.
Okay, and Tim has already mentioned the fact that there'll be less emissions, at least locally, maybe by the power plant.
Right.
There are some more emissions, but all right. Now, are you guys actually building electric cars?
Well, we're building electric power systems and energy storage systems, and then we integrate those into cars. The cars are, for us, are a laboratory that we install these systems into. They're a laboratory, and so as of yet, we have not built an electric car. We've only converted electric cars. But we hope to get closer and closer to the car business in the future.
Okay, well, tell me, when you say you build the power systems, if I'm not an engineer doing this, I might not know what that is. Tell me what it is that you put in the car, what it does.
Well, there's a couple of components to an electric vehicle system. Like everybody knows about batteries. Well, there's batteries, there's the electric motor, there's the electric controller, there's the charger. So all of these components are individuals, for the lack of a better word. Now, when we put them into a vehicle, we have to integrate them together. They have to work as a system. When they work as a system, then you can realize the full potential of the electric vehicle. So how we get these components integrated and how we place them into the vehicle so that we maintain the drivability of this car. The car has to remain nimble. That is the key competencies of our companies. We're not only developing technology, we're figuring better ways to integrate it and make it into a better vehicle.
And the system has to work.
Yeah, well, I assume that's well, yes.
No, that's very difficult.
Yeah,
that's a very difficult
But
thing.
from a naive point of view, when I think of an electric car, I think, all right, here's your car. It's got the 4 wheels, it's standard. It's got an electric motor that's connected to the back wheels. You got a battery up here. Well, couldn't you just have a toggle switch on, off?
But then you would only travel at one velocity. You want to be able to travel at multiple speeds, slower, faster, right? If you just had a switch on and off, you'd only be able to travel at the same rate.
It's not even like a Lionel train.
well, there you would just have,
have a transformer.
All right, so you go.
And one thing that I would like to add to your first question is we could generate electricity through renewable sources. We don't have to burn coal. So the electric vehicle offers the potential down the road for us to be able to utilize different sources of energy. It doesn't have to be from oil, from coal, from any of these other non-renewable sources.
I guess just to add on or to pile on, you know, we have a dumb grid now. We don't have a smart grid. The electric vehicle gives the world a chance to have a smart grid, because you can redeploy that power.
So it's like inventing better light bulbs in a sense, because no matter how they generate the power, the better light bulb can take advantage of whatever electric source you've got.
Part of that, but the light bulb will also run off of another source. So you don't have to keep burning the same fuel to produce the source.
Now
it's flexible.
But people have been building electric vehicles, and I'm thinking now things like subway trains, electric locomotives and so on. They've been doing that since a guy by the name of Sprague invented an electric trolley back in, 1880 something or other. They've been doing this for a long time. Why do we need a new company to develop this technology yet again? Because
these technologies, in the form that you've seen this technology, like for example a rail, it's connected to the grid in one form or another. When you have an electric automobile, you're fully mobile. You have only one source of energy, and you have to treat that energy with respect. And you have to make sure that it gets you to where you want. So the technology application is much different. And thus it justifies different companies with different approaches, different technologies.
Have you gone beyond the workbench? I mean, you said something about modifying cars. Obviously, your part of the electric car is the control hardware, and I assume there's a lot of software, right?
Absolutely, lots of it.
Oh, okay, so you're developing that on a workbench. What have you actually put into a car? Tell me about that.
Well, everything that we develop on the workshop goes into the car. Everything. You know, we use the cars, the vehicles for us are all part of research and development. See, when we hook things up on the workbench and we all get it to work, it might work on the workbench, but when you put it in a real environment where everything shakes, where things heat up, it might not work. So what we do is we put these systems into a race car, for an example, where we test it to the limit. We put it in another road car that we converted, which is a electric Miata, which you drove earlier today. We put it into scooters, go-karts, all kinds of things, so that this environment tells us different behaviors of the system. It gives us different insights.
So we stress test in the race car. We found that there were terrible problems. And we found out, and it was really fortunate, because that's how we ended up at NASA, because that's what NASA does. NASA stress tests everything to try to find out when it's going to fail and how to make it better so that when it goes up into space, it won't fail. So and they invited us to come into the NASA Research Park for that reason. So it's the stress testing that really led us to the problems immediately, and then we began to solve the problems. And the first problem we went after was battery management, because battery management is the brain of the car, basically.
Is that the problem? I mean, you said you had problems with when you put your system into a race car. Of course, I want to know, what kind of problem did you have? Obviously, you didn't win the race.
We had batteries that were not catching on fire, but we had batteries that were being destroyed. You know, we didn't have burnt cables particularly, but we had failures of all types of components. We had overheating of the motor and the drive.
That's true.
And so all of the things that really anyone who's developing an electric system, these are the problems that you really have to solve these problems to make the system work. You know, the system has to work like our Miata. It's got to go for 5,000 miles and be charged, 1,000 times.
I have to say I was being somewhat disingenuous earlier when I said, have you actually put this in the car? Because as you point out, before the program, Tim took me outside into the parking lot, threw me into this Miata. It's a Miata.
Electric Miata. Miata. That's where
at least it's not an Miata.
No.
Okay, it's an electric Miata. And we just drove across a couple of miles of Mountain View real estate here. Yeah. Maybe you should describe what it's like to drive the electric car, because you do it every day. You commute in one, right?
Well, I think I'll do just a teens, and then I'm going to have Dante chime in. But basically, it changed my life, because you never have to go into a service station. The car needs absolutely no maintenance at all. It's very quiet. I drive with the top down, just one person with my white stickers in the commuter lane, passing 400 cars going to work, passing 400 cars coming back from work, and it is really a game changer.
It's pretty empowering, and it's just amazing for me to be able to watch this clump of technology work together. When you think about what makes an EV, and you think about all the individual components, they all want to do their own thing. To get them all synchronized so that they're actually able to work in a concerto together to satisfy a common goal is pretty exhilarating from an engineering point of view.
Okay, well, we're going to come back. I want to ask you some of the real practical questions, like how often I have to charge this thing. Once we come back, we're going to take a break for this message.
Unlike commercial or public TV stations, we at KMVT Community Television focus on Silicon Valley residents, organizations, and businesses. We televise to over 100,000 viewers in Santa Clara County, with syndication potential to more than 1 million in the greater San Francisco Bay Area. We at KMVT connect Silicon Valley communities, empower people, and affect change. Do you?
Silicon Valley Buzz. I'm Seth Shostak, and I'm talking with Tim Collins and Dante Zeviar from KleenSpeed Technologies, who develop technology for electric cars. You commute every day, Tim, from San Francisco, right? Back and forth to Mountain View. What is that, like 80 miles or something like that?
Yeah, it's 40 miles each way, exactly.
40 miles each way. Do you have to charge up your car every night?
I charge it at home, and I charge it when I get to our shop at NASA. I don't have to. I could go both ways, but I mean, I think if you own an electric car, you kind of learn immediately, you want to be ready for maximum mileage. So wherever you go, if you can charge it, you charge it.
Okay, so how far could you go? I mean, this, of course, is a kind of a test vehicle in a way. This is a converted Miata. But if you didn't recharge it, when would it roll to a stop?
Well, it's about 80 miles.
So,
and depending on the speeds you drive it, I mean, if you drive it very, very slowly, you'll go further than if you drive it at 60, 65 miles an hour.
Where's the optimal mileage? With gasoline cars, it's typically 40 miles an hour.
Yeah, it's probably that. Yeah, 40.
About the same.
Yeah, around 40.
But that has to do with the friction, I suppose.
Yeah, well, we have low roll resistance tires on it, and and so it's comfy at 45 miles an hour. But it's also very comfortable at 85 miles an hour. But of course, we don't drive it that fast.
Wooden wheels would be more efficient, maybe steel wheels. I don't know, something like that. Well, listen, we've been talking about these test vehicles and so forth, but we have some tape here. We have some actual video of what it looks like. Maybe you can tell me what we're looking at here.
Well, that's Dante looking at our e-cart, and he just put the KleenSpeed logo on it. So
was that the hard part?
We have 250 miles of testing on that cart, and that's one of the ways we really test all of our components, including the battery management system that we've been developing. So here we're out on the apron of the tarmac. This is in Nevada. This is the first car we ever converted. And you're going about 85, 90 miles an hour in that car. And it's got here we are at Laguna Seca, and coming up going into turn 3. And now,
there were some numbers there on that.
That's right.
It's going 116 miles an hour or something. But
right.
the horsepower, reading those numbers, is actually not that high. I mean, compared to a typical racing car, right?
That's a good clip.
Well,
that's good. That had nothing to do with the electric motor.
Oh, is that right? That's good.
It was testing in progress. It's very important to test these systems to their actual limit, because it gives you an idea of what the system is capable.
But have you actually raced these cars?
Yes, they have been. The one clip of the race car you saw at Laguna Seca, that car has been raced for the past 2 years at Laguna Seca. It's a part of this competition called Refuel, and we were fortunate enough to win the title the last 2 years. So what's going to happen this month, June 26th, we're going to go there again to try to defend our title from last year. So if you have nothing better to do on that Sunday, you're more than welcome to come and join us.
Are you collecting a bunch of trophies there at KleenSpeed? Is that the deal?
Yeah, but we started out with the idea of developing technology. We didn't really want to go out and win trophies.
Okay,
that's just a positive result of what
it
we're
isn't
doing.
about putting decals on the side of the car and advertising.
Well,
right?
it's best to be the head of your peer group.
Well, let's talk about your peer group, because I don't need to tell you. There are other people who are in the electric car business. There's the Nissan Leaf, right? There's the Tesla Roadster right here in the South Bay, I believe, and also the Chevy Volt. I mean, these are heavy-duty players. What are you offering the car buyer that these guys aren't?
Well, we have actually in our website we have a comparison of the Nissan Leaf and the Iata, a road test comparison. So they do about the same things. I've driven the Nissan Leaf, of course, and I think it's a very fine car. It's a credit to electric vehicles. So I have no complaints about it at all. I think the IATA is a lot more fun. It's about the same price, and it maybe goes a little further than the Nissan Leaf.
I was going to say, I did drive the IATA. Did I mispronounce
the
it?
IATA.
Yeah, you got
it.
IATA. Yeah. I'll get it right. Maybe I won't. The IATA before the program. As I say, we just drove around here. And it took a little bit of getting used to, because you got to essentially put the pedal to the metal. You got to floor the accelerator. There's no clutch, really. There are gears, but there's no clutch. And it takes a while, but it's kind of quiet. And it has this sense, I must say, of having a lot more power than you think it does. There was something about it that was...
No, it'll sneak up on you. The torque enables you to accelerate very quickly, and because it's so quiet, it sneaks up on you. It really does.
See, the electric motor is a much different piece of technology than the internal combustion engine in that it develops full torque at 0 RPM, and it develops it horizontally and over a wider range of RPM. So that is, even though that the horsepower is not there, you might have mentioned that the race car is only 200 horsepower, even though the horsepower numbers are not comparable to real race cars, the torque levels are. And what we can do with the whole system, like for an example, we can eliminate the transmission as a result of this high initial torque. So the drivetrain efficiency, the response times are reduced. So the car feels peppier than it actually might appear, judging from its numbers.
Maybe I missed that, you know, the noise of a powerful car. Should I have that because of pedestrians? Maybe they wouldn't hear me sneaking up on them.
No, I think we're going to have to develop, generally the rule is 18 miles an hour or less. There should be a noise emitted from the car to alert pedestrians. We haven't put that in the car yet, but it'll be part of our, it's actually kind of part of our whole BMS package. So we will develop that. But we don't have it in the IATA now, so I'm just very careful.
Let me get back to some of the technology questions. How long do the batteries go before you have to, you know, switch them out in a typical electric car these days?
Well, one of the things we discovered is that if you have a really good battery management charge system, they're going to last a lot longer. But 1,000 to 1,500 charges is what you can look at for an electric vehicle.
So a couple of years.
Couple of years, for sure,
at least a couple of years.
Okay, and what about, I mean, you know, sometimes I have these dreams that if we could only, you know, increase the efficiency of storage batteries by 30%, we would change the world, right?
That's happening. This is ongoing research.
It is happening.
Yes, it is happening, and it's going to get better and better and better. The efficiencies, the energy densities of batteries are going to improve.
Okay.
But so will the electronics. See, everybody thinks of batteries as this homologous unit. Well, in reality, a battery is made up of individual little cells. You know, our battery in our race car has, you know, over 100 cells. So you have to monitor each cell, and depending upon how each cell functions, that's how the whole battery pack functions. So that technology, including with the battery chemistries and enclosure technology, that will all improve and result in a better performing car.
So to be precise, Seth, the battery pack should last 5 years, 3 to 5 years, 1,500. With a good battery management charge system, it's going to last longer. When the battery pack's finished, it's going to be down to about 60–70% capacity. And it's going to be used for standby power for nuclear reactors or for computer centers.
I mean, there's something to do with these batteries? If a million people had these cars, would...
Yeah, so there's going to be you know, we believe the battery pack, we believe when you buy a car, you shouldn't buy 3,000 gallons of gasoline. So why should you buy a battery as part of an electric car? So any car we ever sell to anyone, we will lease the battery to them. So looking at it that way, the battery has a resale value, just like a lease car. When it comes off lease, it's going to go do something else.
And there are several life cycles to batteries. The first one being in the vehicle. When it drops to about 70–80% of its original capacity, we can use it for standalone power supplies for hospitals. Yeah. After that life cycle, we can put them in another cycle. After that cycle, they can even be recycled, and the copper and material content within the battery is also financially considerable.
Interesting. It doesn't go into the landfill.
No.
When we come back, we have a couple of messages. When we come back, I want to talk to you guys about what the potential is here, no pun intended, but in terms of the worldwide market and where you see the company going.
For want of a block, the structure was lost. For want of a structure, the numbers were lost. For want of the numbers, the students were lost. And all for the want of the building blocks. Don't let this happen to us. Support the building blocks of math education. Shop local, shop Mountain View to support math in our schools. Part of every dollar you spend at sponsoring stores goes to the Mountain View Math Acceleration Project.
Talking electric cars with Tim Collins and Dante Zeviar from KleenSpeed Technologies. All right, gentlemen, how many employees does KleenSpeed Technologies have these days?
Well, we have 7. We have 5 engineers. We have a vice president of marketing and branding, and we have a fabrication and a sort of a fabrication installation person, kind of a special products person. And that doesn't include me because I'm not on salary. So I work for free. So I guess we have 8 people. But in addition to that, we have about 15 technical people who have day jobs, who work on weekends and at nights helping us. So our firepower is about, in the 20s.
Okay, so you guys are a classic startup, right?
We are. We're in Silicon Valley.
And startups often start up in a garage. That sounds like it would be appropriate for this particular company. All right, how do you see, as it were, down the road for KleenSpeed Technologies? I mean, you guys, I don't know, do you want to be in the car manufacturing business, or you want to be in the, the control system business, right? I mean, you're developing the technology. Do you want to license the technology? Are you going to set up manufacturing here in this? I mean, how do you see the future 5, 10 years down the road?
Well, the electric vehicle industry is a frontier, and it stops at hybrid cars. When you go from a hybrid car to an electric car, it's a different world, because the electric is completely responsible. You have no aid from an internal combustion engine. And so those systems have to work perfectly, and so that's what we do, is we develop the systems and the components, and they go into cars. Now, we've had a multinational company come to us and order a system for one of their concept cars. We call it Project X, and we were honored, to be selected for that. So we will be selling systems and components to car companies and people who need them. So that is an immediate source of business for us. We think we have a really substantial expertise in electric storage. So we're going to be making electric storage systems for people. And then over and above that, we did a study of all the Chinese automobile producers, and I went to China, and we talked to one of the manufacturers who didn't have representation, particularly in the United States, and who we thought we could help with our technology. And so we have a car on the water coming over here that we're going to put our system in.
Car on the water.
They have 9 models of electric cars. So we're going to kind of be in the car business through a Chinese manufacturer.
So you really are going to be in the car business. I mean,
yes,
are there going to be cars that say, KleenSpeed, where you have a logo on the back?
KleenSpeed.
Or powered
X.
by KleenSpeed.
Yeah, well, the car won't be ours, but the system will be ours. It'll be KleenSpeed X.
What's happening is right now we're focusing on all the core competencies necessary to be an automotive OEM. So when we finish developing those components, then it will be more kind of like, well, now we have all the core competencies, we can make a vehicle now. So this is the kind of a roadmap we're in. And what we focus on right now is energy storage systems, electric propulsion systems, and vehicle integration. So these 3 core competencies of KleenSpeed allow us to get into the automotive business when the time comes. When will the time come? Hopefully soon.
Well, he already commutes, he can manage an 80-mile commute. That's, what fraction of people in this country don't need more than 80 miles every day?
70% drive less than 40 miles, from what General Motors tells us.
70%
of the people in the United States
the
drive less
majority
than
of people
40 miles.
would be happy with your car,
Yeah.
except for maybe going on vacations or climbing the Rockies
Yeah.
or something like that.
Yeah.
Okay, so that's really, I mean, this is a huge market. Given that, I mean, are there other applications? I mean, what about, transit, or what about buses?
Absolutely.
What about other kinds of vehicles?
Buses, trucks, heavy-duty trucks, buses, any kind of captive tug or that type of vehicle in industry. So there's going to be, well, of course, electric motors, you know, powered automation.
Yeah, well, there are electric motors everywhere.
Yeah.
I can imagine that indeed, I mean, if you put a lot of solar cells on the top of your house, well, that's a great thing, except that at night, of course, it doesn't work. So if you had a, you know, one of your systems in the basement with the batteries and the control system, maybe you could run all the appliances in your kitchen with one of your control systems. I mean, this isn't limited to cars.
You should be able to run your house off your electric car if you want to. That's what you'll be able to do in the future.
Well, that's kind of an interesting
Yeah.
idea.
I mean,
that's the smart grid.
the technologies resulting from our core competencies are widely applicable in several different segments, not just automobiles. That's why we're focusing on these core technologies. See what I'm saying?
Yeah, I see what you're saying. Okay, and I don't know if you can tell me this. I mean, I'm not trying to find out when the IPO is so I can buy the stock, but you know, when do you expect to see that first sale of a car with your technology in it?
Well, I think it could be this year. I mean, it could be this year if we take this roller that's coming in off the boat and we put our system in it. We can sell it. It's been crash tested in the U.S. and so it would be saleable. We couldn't sell 1,000 of them, but we could sell 1 or 2 of them for sure. So we could get started. But if you want to look at dreams, Seth, the electric power system needs a car to be designed for the power system. So in the future, cars are going to be very light and they're going to be made out of different types of carbon fiber and composites.
Well, I want to thank both of you. Tim Collins, founder, president of KleenSpeed, Dante Zevillar, executive vice president and chief technology of KleenSpeed Technologies. And I want to thank you all for joining us here on Silicon Valley Buzz. More power to you, gentlemen.
Thank you.
Be sure to join us next time. This will be a monthly program about the latest in technology and other innovation here in the Silicon Valley. I'm Seth Shostak. Thank you for joining us here in the most innovative spot on Earth.